Hey, it's Mr. Lum again, and we're going to be doing some more solubility chemistry. And for this lesson, we're going to be looking at predicting if a precipitate will form using KSP and what we're going to be calling our trial KSP or TIP. Anyways, so what I've written down here is if a certain amount of solute is added to water, we can use calculations to determine if a precipitate is going to form. So if a precipitate forms, like when you have something like this, when you have say A, B solid, and it forms an equilibrium and makes A plus B minus. If we multiply at equilibrium, if we multiply the concentration of A plus and B minus together, what we'll get is a value that is known as KSP. And this is just the solubility product. It's the maximum concentration we can get of A plus and B minus multiplied together, and it's going to equal this constant value. So what we can figure out is if we just threw in some A plus and B minus into a solution, we can figure out, is it going to form a precipitate? And how we know that is, well, if the trial ion product, or if this times this is greater than the KSP, then a precipitate forms. So again, if the amount that we throw in there, if the trial ion product is greater than the KSP, a precipitate will form. So a precipitate will form if the trial ion product, TIP, is greater than the KSP, then a precipitate form. If the trial ion product, or the TIP, is less than KSP, a precipitate will not form. So in a scenario where it is TIP is less than KSP, a precipitate will not form. Okay, so again, we're going to be comparing our trial ion product to the actual KSP from our charts here. Now let's take a look at a real problem. Okay, so here we see a question that says, will a precipitate form if we have a concentration of silver at 6.22 times 10 to the minus 9 and a concentration of iodine or iodide ions, which is 4.35 times 10 to the minus 10. So let's write out just a quick formula here, and it'll be AGI Okay, so here's our formula. So solid, aqueous, and aqueous. Now, using from our table, we know that the KSP for silver iodide is 8.5 times 10 to the minus 17. So KSP for this is 8.5 times 10 to the minus 17. Okay, so what we're going to do is we're going to find our trial ion product. Our trial ion product. And our trial ion product is going to be, well, our trial ion product is like our KSP, is our KSP test. So we're going to just our trial ion product, which is very similar to KSP in some ways, is going to be the concentration of Ag times the concentration of iodine. Okay, because it's a 1 to 1 to 1 ratio, so there's no squaring or cubing of anything. And what we see is our trial ion product is going to equal 6.22 times 10 to the minus 9, and that is going to be multiplied against 4.35 times 10 to the minus 10. And we get a trial ion product that is equal to 2.71 times 10 to the minus 18. So we're then going to compare our trial ion product to our KSP. So what we see here, here's our trial ion product is 2.71 times 10 to the minus 18, which is a smaller number than 8.5 times 10 to the minus 17. So, in other words, KSP is bigger than our trial ion product, or our trial ion product is less than our KSP. Therefore, no precipitate forms, no PPT forms. Okay, so if we had this concentration of silver and this concentration of iodide in a solution, there won't be any precipitates being formed. Let's look at another problem right here. Here's a concentration of sulfate, and it says how many grams of calcium needs to be added to a 250 milliliter solution for a precipitate just to start to form. So in other words, we want a precipitate just to start to form. So our ion product needs to equal our KSP, because the KSP is at the verge, the point at just where a precipitate is just starting to form. Okay, so the first step that we're going to do is, well, we'll write a little formula right here. So again, CaSO4, and that's going to be Ca . Okay, so here's our formula. It's a 1 to 1 to 1 ratio. And the first step that we're going to do is we're going to calculate well, the concentration of calcium in the solution here. So the first thing we should do is, we know that KSP from our table is equal to this number down here, and KSP, if we made a formula, is going to equal the concentration of Ca plus 2 and times the concentration of SO4 minus 2. Now we know some of these values, so again, KSP is going to be 7.1 times 10 to the minus 5. So let's fill in some of these things. 7.1 times 10 to the minus 5. And that's right from our table that we're given. And that's going to equal our concentration of calcium. And we're given our concentration of sulfate, which is 3.8 times 10 to the minus 3. We solve for calcium, the concentration of calcium. And when we find that, it's going to be 7.1 times 10 to the minus 5 divided by 3.8 times 10 to the minus 3. And I did this calculation already, and we get a number like 0.01868 molarity. Okay. Now, it says how many grams of this, and what we solved here is moles per liter, or the concentration of calcium. So we need to take this number right here and change it into grams. So again, I'm going to take the concentration of calcium, which is 0.01868, and that's moles per 1 liter. I'm writing a little bit crooked. Okay, and we're going to multiply that by our volume that we're given. Okay, so we're told it's 250 milliliters, so I'm going to multiply this by 0.250 liters, which is the same as 250 milliliters. So 0.2500 liters. And what is that going to do is that's going to make our liters cancel. And now our unit, if we have 0.01868 times 0.25, that's going to have moles of calcium. Now we want to know grams of calcium. So we're going to times this by the molar mass of calcium, which happens to be 40.1 grams per mole. And what we see here is, well, moles cancels with moles, and so we're left with grams of calcium. And if we do this calculation, we should come up with a number like 0.1873 grams of calcium. Now, what we see here is if we were to do this all on one line equation, we would see that the smallest number of significant figures right here is 2 sig figs, and our answer needs to be reported in 2 sig figs. So our final answer should be something like 0.19 grams of calcium. Okay, and we write up a little sentence to explain ourselves, and that is our final answer right there. Okay, a little bit messy with my very large divided by symbol, but hopefully you get the basic idea.